In the last video, I looked at taking the Laplace transform of these discontinuous functions using the step function and the window function. Now I want to look at taking the inverse transform. So we have the inverse transform of capital F of s e to the minus as is little f of t evaluated at t minus a times u of t minus a. And in this case, the transform of little f of t is capital F of s. So let's do some examples of this. Here I have 1 over s cubed e to the minus 2s, and I want to take the inverse transform. So we're going to start with this term here, and we're going to look at just what is the transform of that. Using our table, we get that the transform of 1 over s cubed is 1/2 t squared. And we need to evaluate this at t minus a. In this case, a is 2, so I have t minus 2 times u t minus 2. So we have 1/2 times t minus 2 squared u t minus 2. Let's now look at solving this initial value problem with the discontinuous function. So I'm going to start by rewriting this as y double prime plus 1/4 y is equal to, we would have 1 times u of t minus u t minus 1. We then have negative 1 times u of t minus 1, and then negative 1 times negative u of t minus 2. So I'm going to rewrite this as ut minus 2u t minus 1 plus u of t minus 2. I now want to take the transform, and when I do, I'm going to get s squared times capital Y plus 1/4 y is equal to, the transform of u to the t is going to be 1 over s minus 2 times e to the minus s over s plus e to the minus 2s over s. And now this is what I need to solve. So I'm going to go ahead and factor the right-hand side into s squared plus 1/4 y. The right-hand side will be 1 over s minus 2 e to the minus s over s plus e to the minus 2s over s. So as we scroll down, I'm going to divide, and I get y is equal to 1 over s times s squared plus 1/4 minus 2 e to the minus s over s squared plus 1/4 plus e to the minus 2s over s times s squared plus 1/4. Let's start by considering just this first term here, 1 over s times s squared plus 1/4. When I set up my partial fractions, I'm going to have an a over s, a bs over s squared plus 1/4, and then in this case, I've already written this as s minus a squared plus b squared. A is 0 and b is 1/2. So I'll need a 1/2 c over s squared plus 1/4. That then gives me 1 is equal to a times s squared plus 1/4 plus bs squared plus 1/2 cs. I can then start by letting s be equal to 0. I would then have 1/4 a is equal plus 0 plus 0. So 4 is equal to a. I'm going to go ahead and rewrite this as 1 equal to as squared plus 1/4 a plus bs squared plus 1/2 cs s squared terms, say a plus b, there's no s squared on the right-hand side, so I have 0 equal to a plus b. We know a is 4, so b must be equal to -4. Looking at my s terms, I have 0 s terms on the left and 1/2 c on the right. So that tells me that c is equal to 0. From there, I'm going to rewrite all of my capital Y. I have a over s plus bs over s squared plus 1/4. This third term here is equal to 0. If I scroll up just a little bit, I can see that these two are almost exactly the same. Minus 2 e to the minus s times exactly what I just found. ⅓. And then an e to the minus 2s times the thing I just found. So, while this looked really bad, it actually wasn't too bad of a partial fraction. We now need to take our inverse transforms. The inverse transform of 4 over s is just 4. The inverse transform of this is going to be -4 times cosine 1/2 t, so I'm going to write that as t over 2. I'm then going to have a -2 times. This e to the minus s means I'm going to have a u to the t minus 1 times the inverse transform of this, which we just found, evaluated at t minus a, so evaluated at t minus 1, plus my third term, the e to the minus 2s, means I'm going to have a u to the t minus 2 times the inverse transform of this, which we've already found, evaluated at t minus 2. So as we go through and do this, we have 4 minus 4 cosine t minus 2 minus 2u to the t minus 1 times 4 minus 4 cosine. Instead of t, I'm going to write t minus 1 over 2 plus u to the t minus 2 times 4 minus 4 cosine, and instead of t, I write t minus 2 over 2. So now I have the full solution.